Hey guys, we're back with the notes for 8.6. We're going to be solving quadratics from a graphing calculator. Now, if you're watching this video, you should be an asynchronous learner, which means that you are doing this from home without a calculator, and you're going to be doing it on Desmos. Okay, so first thing I would suggest you do is go ahead and open Desmos.com on your own computer in a side browser so that you can kind of play around with it because yours might not look exactly like mine when you open it up. Okay. Now that you have that open, I'm going to ask that you pause the screen and copy what you see. Hopefully you have this part in the printed sheet of paper that you picked up so that you don't have to copy it all down. If you didn't, I would write it down on a separate sheet of paper and staple it into your book. You can press play when you're ready. Wonderful. Okay, so let's go ahead and talk about a couple things. First of all, the name of this graph is called a parabola. It's not Ebola's cousin. It's not parabola. It's parabola. Okay, that is shaped like a U. It should be facing up when we talk about our parent function. Parent function, you can kind of think about this like the OG, the original graph. Everything is going to change from him. So we call him the parent function. It's basically the most simple equation of an x squared. So x squared equals 0. That's it. That's your whole equation. If we were going to solve that, obviously you would square root both sides. You would say x equals 0. You would not put plus or minus on it. You would just say my x is 0. So what does that mean on a graph? Well, we have a couple things you need to know. First thing you need to know is that if you are looking at a graph, the amount of solutions is how many times your graph touches the x-axis. This problem only has one solution because it only touches the graph one time. It kind of bounces off of it. If my x-axis was going like through here, like if the graph was farther down, then I would say I have two solutions. It might be like a positive and a negative 2 if my answer was plus or minus 2. Or it might be decimal numbers, right? We know we can get decimals at this point, okay? So how many answers you have is how many times it touches the x-axis. Second thing you need to know is what the solutions are. The solutions are where it crosses the x-axis. So this graph has one solution. That solution is 0 because that is where the graph crosses the x-axis. All right, let me zoom this out just a little bit again. Try and put him back. There we go. All right, so what does it mean to be a solution? Well, we have a lot of words in algebra that mean the same thing. So solution would be the zeros to the problem. It would be what makes the equation equal 0. We would call it the roots, like if you square rooted both sides, it would be the roots. X-intercepts is like what we said, where it crosses the x-axis. And really all of those are the solution to the problem. It is me solving for x, okay? All right, so let's go ahead and come down here and let's start talking a little bit about how to use the Desmos.com. Okay, let's look as if we're going to solve problem 1 right here. Problem 1, you technically wouldn't need a calculator because the graph's already provided, but I want to show you how to do it as we go through this. First thing, you need to make sure that all equations are set equal to 0 because when you type them in the calculator, you are going to start with f of x. So f parenthesis x parenthesis equals, and then you can type in your equation. So x squared minus 2x minus 8. Okay, this graph is a little bit off the picture, so I'm going to hit zoom out so I can see it. There we go. That matches exactly like what I'm looking at on the screen. If I was ever going to need to get a table to make my own graph on paper, I would hit this little plus sign, choose table, and I would edit this. Oops. I would edit this to make it say x, regular x, not x1. And I would make this say f of x. That way it will use the equation that I just typed in, okay? The colors may be different, but it's still going to be the same thing. I would have to edit these, and then you can type in whatever numbers you want. So like if I know I need -3, -2, -1, 0, 1, 2, and 3, I just type those, and it will automatically find the y values for me. Remember, f of x is just y, okay? All right, so let's go through what the actual answer looks like. I'm going to move back to my Notability over here, my notes page. So if I'm looking at this problem, I would ask you, to find the solutions, I need to know how many solutions I'm going to have. Well, how many times does my graph cross the x-axis? Crosses once right here and once right here. You should be able to tell the x-axis is the bold black line. Okay. Second thing I need to know is where it crosses. That way I know what my solutions are. So on this one, if 0 is right here, that means I have -1, -2, and then 1, 2, 3, 4. So my solutions are -2 and 4. If I was trying to find that on my graphing calculator, let me zoom this out one more time. Here's how I would do it. I would first of all click on the graph, click on the red graph. There will always pop up a little gray dot or a little gray point anywhere that you have an x-intercept. Make sure you're not looking on the y-axis, you're on the x-axis. So if I look at this one, it's -2, 0. If I look at this one, it's 4, 0. We're solving for x's, right? So I would only write down the x numbers. So -2 is the x and 4 is the x. That's how I would write my solution. Okay? All right, let's go back to the paper. I'm not going to use the calculator to do number 2 because, again, I have the graph already for that one. So if I look at problem 2, I'm going to say, all right, where does this cross the x-axis and how many times? Roots and solutions are the same thing. So I would say this one crosses 2 times. It crosses at a -2 and then 1, 2, 3. So my answer is -2, 3. Remember that we are always writing these least to greatest. Another thing that people get confused about is in the past, we have written these by changing the signs. Like when we were factoring, we had to change signs. You don't have to do that here. Whatever the number is, that's what you're writing down. Okay? All right, let's go ahead and go to the next page, and we'll jump back and forth to the calculator when we need to. Okay? First and most importantly, I want you to put a big note on top of here that says that you must make it equal 0 first. Copy that down real quick. You have to make these equations equal 0 first because that's the only way you're going to be able to make them do f of x. Okay? So I'm going to do that on all 4 problems. Remember, if you move something to the other side of the equation, it has to change sign. So x squared minus 4 equals 0. This one would say x squared minus 6x plus 9, because we're moving it to the other side, equals 0. Number 5 would be 2x squared minus 11x plus 5, because we move the 5 over. And this last one is already equal to 0, so I don't have to do anything with it. Okay? All right, I'm moving into the calculator. So if you ever think I'm moving too fast, remember you can always pause this and go back and get what you need. All right, so I'm going to leave all my formatting in here already. Okay? I'm not going to delete or I'm not going to hit the X button. All I'm going to do is edit it. That way I don't have to start over. Okay? So up here, I'm just going to start typing again, x squared minus 4. When I do that, it is automatically going to change my table to be what I want it to be. Okay? All right, so if I look at this problem, I'm graphing a couple points. I've got -3, 5. So let me zoom this guy in a little bit. There we go. So -3, 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. Remember, if I'm going too fast, you can pause it. I am expecting you to draw these graphs. And then when we write our solution, we're asking, how many times does it cross the x-axis and where does it cross? This one crosses 2 times. They happen to be whole numbers. Crosses at -2 and it crosses at +2. I don't really have to use the calculator again once I draw the graph on my paper because I know that right here, -2 and +2, those were already whole numbers, right? In my table right here, it was already the number that I knew made it equal 0. Okay? All right, let's try the next one. Let's move this over just a little bit so you can see it. There we go. All right, so again, I'm not going to delete anything. I'm just going to edit it in the calculator. X squared minus 6x plus 9. Make sure you've changed the sign. You can always click on the graph and drag it around if it makes it easier for you to see it. But this one, I don't have very many points to graph. So I can't do -336 or -225. First one I can actually graph is 1, 4, and then 2, 1, and then 3, 0. But you can see in your picture that obviously it's still shaped like a U. So if you wanted to come back here and type some more points, like 4, 5, it would keep going for you. So 4, 1, and 5, 4. That way I have my full shape. It's important. You don't want to draw something that looks like this if that's not the shape of the graph. Okay? Go ahead and connect my dots. Then I would ask myself, how many times does this graph touch the x-axis? Only one time. So I'm only going to write one answer. X equals, and where does it touch? It touches on the positive 3. If you weren't sure, you can come back to your graph, click on the red graph, and then that little gray point will pop up and it will tell you what the number is. Okay. All right, let's go to number 5 down here. Okay, number 5, I'm not going to delete it, I'm just going to edit it. I have to put a little 2 in front of my x squared this time. So 2x squared minus 11x plus 5. All right, I'm going to drag my graph up a little bit so I can see kind of where it all is going. And I'm going to graph it on my paper. So the 56, 35, obviously those won't fit, but 0, 5 will. 1, negative 4 will. 2, negative 9 goes off the graph, so all I can fit is this right now. It's going to go down below. And then it's going to circle back up. So I can do 4, negative 7 doesn't really fit, but 5, 0 fits. And maybe we see where 6 goes, just in case. 6, 11. All right, so it doesn't really fit. This one's kind of down here, 4, negative 7. But my graph would look like this. I'm going to request that you do not connect down here, or if you do decide to connect, make sure it goes way down. Okay, it should not go like a corner, like you should not have it like this. Okay, so either don't connect it or connect it really far down like that. Okay. All right, so if I look at this problem, it crosses the x-axis 2 times. I know one of them right here was the whole number 5 because we dotted that one. But this doesn't have a whole number. This one I definitely need to go back to the calculator to see. So I know my first 0 is 5. Let's find the other one. If I click on the red graph, it's going to give me that the gray little dot, 5. But this one's a decimal, 0.5. You can write 0.5, or you could use that as a fraction and do 1/2. I'll take either one. But when you write your solutions, remember to go least to greatest. So 0.5 comma 5, or you could do 1/2 comma 5. I would take either way. Okay. All right, we're going to do one more like this. Let me move this guy over. All right, we're doing number 6. So number 6, I'm not going to delete it, just going to edit it. X squared plus 3x plus 7. Move my graph so I can see what it looks like. All right, we can't really fit negative 3, 7. I guess it's kind of off the graph just a little bit. Negative 2, 5, negative 1, 5, and 0, 7. So he's kind of up here a little bit. So if I asked you, how many times does this graph cross the x-axis? You would say none. So let's make a note. Doesn't touch x-axis. So if I can't have a number and I don't have any answers, think about what we normally say to that. How would we normally answer those questions? Well, we would say it has non-real answers. Don't say none, don't say NRA. I am not going to give you credit for that. You need to type out the words non-real answers. Okay? That's the answer you're going to use anytime you type it into a graph and you notice it doesn't cross the x-axis. I just don't have an answer. Okay? All right. If you need to pause the screen, let me zoom out real quick. Whoop. There you go. If you need to pause the screen, copy it down, go for it. Otherwise, we're quickly going to go through the back. All right, go into the back. First thing I'm going to do, remember you have to make it equal 0 first. So number 7's already done. Let's do 8 while we're at it. So 6x squared minus 13x minus 5 equals 0. Remember, you can always pause the screen if I'm going too fast. Number 9, 3x squared minus 9x equals 0. And number 10 is already done. All right, I want to show you how to fill out the table. You've already kind of seen it on the calculator, but we're going to go through that anyways. All right, so moving him back over here. I don't really need the graph on this problem, okay? So I'm going to leave this screen here and just kind of bounce back and forth. X squared plus 3x plus 2. So I'm changing this to a 2. And I want to make the numbers match. So right now, I don't have a negative 5 or a negative 4, so I would need to type them in. So I can type over anything I want. Negative 5, negative 4 here. Okay, so negative 5 takes me to 12. Negative 4 takes me to 6, and then I'm following back up here for 2, 0, 0, 6, and oops, I did that wrong. Negative 3 was 2, 0, 0, 1. Oh, I missed the 2, sorry. 2 and 6. All right, so when you're looking to find zeros, if I was kind of pointing out literally what these words say, you're asking what x's make this table go to 0, and that would be these two answers. So x equals negative 1 and negative 2. Make sure you go least to greatest, so negative 2 comma negative 1. All right, I'm going to slide this graph over. I'm going to type in our new equation. So we've got 6x squared. We're going to change this to a minus 13 and a minus 5. All right, I already have negative 3 on here, so we're going 88, 45, 14, negative 5, negative 12, negative 7. But notice that I don't want to write down this number because I need it to go back to a 3 so I can use it. So 3 actually goes to 10. All right, so we're looking on this problem to see where the zeros are. Okay, what x's take me to 0? Well, none of the ones in the table take me there. So if I come back to my graph, I'm going to zoom out a little bit. I can click on the red graph, and I'm trying to find those little gray dots on the x-axis. So my little gray dots tell me that my solutions are negative 0.333, and my other one is at 2.5. That's all I need. Okay. All right, let's scroll up a little bit. We're going to go to number 9. Number 9, I'm going to edit my equation. We've got 3x squared minus 9x. Looking at the table, I don't need the first couple. My first line I'm looking for is this negative 1. So we're going to write down 12, 0, negative 6. Oops, sorry. 12, 0. Yeah, negative 6, negative 6. 3 goes to 0. Remember, I need to change this back to a regular 4. And then we've got 12 and 30. So if I'm looking for my zeros, I can see them, right? I'm looking for what x numbers make my y value a 0. My solutions are 0 and 3. Think about it this way. There could never be more than 2 answers, right? Because if I'm thinking about a parabola, a u can only cross the x-axis twice. If it had more x's, like x to the 3rd power in it, then I could have more answers. But once you have 2 answers, that's the most you could ever have. That's how I know I don't have to go back to my graph. All right, last one, number 10. Edit my equation. This time it's going to be a negative. So negative x squared plus 2x and then minus 3. Starting with negative 2 right here on my numbers I'm writing down. So we're going to go negative 11. Negative 6, negative 3, negative 2, negative 3, negative 6, and negative 11 again. All right, you'll notice that none of these over here have zeros, okay, which means I have to go back and look at my graph. If I look at this graph right here, he does not ever touch the x-axis. So if you do not have any zeros, don't put NA, don't put none, you're going to write non-real answers. Okay. All right, let me zoom this page out real quick. If you needed to copy anything down, go ahead and do that now. And we are all set with this guy.